Okay, the last part for expectation is properties of expected values. Okay, this is also handy. Okay, so earlier we have seen that if it's a function of x, if you know the PMF of x, you can get the expectation of that function of x as well. Here, there are some general rules. Okay, if a and b are constants, okay, they're just constants, they're not related to x at all, then the expectation of, okay, notice here, a times x plus b, it is equivalent to a times the expectation of x plus b. And we're going to do that. We're going to do the proof now here. But before we do that, I just want to say that, well, this result holds for all random variables. It does not have to be discrete. Okay. And in chapter 5, we're going to see this works for the continuous random variable as well. But because in this chapter, we're focused on discrete random variables, so we're going to do the proof here for the discrete random variable case. All right, let's get started. So ax plus b essentially, right, is a function of x. Okay, so as soon as we recognize that, well, we go back to our familiar range. Okay, if I'm trying to get this work, we know that we're gonna get, because there's only x over here, so I will just write px, okay? And then we're gonna have gx, right? And then px. Okay, so if I do that, gx is ax plus b, okay, times px, okay? So when I keep doing, so by the way, let me just make it super clear. All of these ones are small x, okay? Yeah, so yes, the random variable is capital X, okay? But once we're looking at specific values I can take, we're using small x over here. So this thing, if you notice, we can break it into two parts, okay? We have ax px, right? Plus another sum of b times px, okay? So keep in mind that in this general property here, a and b, they're constants, okay? So if they're constants, the summation is being applied to x, okay? So if it's a constant, this constant can go out of the summation, okay? So as soon as we do that, the first term becomes a times the summation. I will just avoid writing it one more time of this. And then the second one becomes this, okay? So notice, what is this? This is actually expectation of x, okay? And what is this? Well, it's not related to expectation per se, okay? It is actually just the sum of all of the PMF values, and we know that they should add up to 1, okay? So this term goes away, this term becomes EX, so we come to our result of A times expectation of X plus B, okay? So the key here is that we will recognize that ax plus b is just actually a function of x. Okay, so once we recognize that, we can follow the result of the expectation of function of random variable. Okay, and then from there, things flow. And I would also just mention that try to recognize this as the expectation of x, and also the sum of all of the possible PMF values should add up to 1. There are some special cases, okay, of this linear ax plus b. If there's no b, then, well, b goes away for both left-hand side and right-hand side, okay? Or if there's only b, like there's no random variable anymore, then the expectation of a constant is going to be itself. So eb will just be b, okay? And then the first one up there is the constant factor. There's no b, so expectation of ax is a times the expectation of x. Okay? So to recap, okay, expectation, okay, ex, okay, or sometimes we use mu, okay, and for discrete random variable, we have defined it, okay. In addition, we have defined for expectation of functions of the random variable, okay, we're replacing x with gx over here, okay, when we're doing that. There's also indicator result, which was left as a live session exercise. So once we get to that, we can talk about it. And then the results about the linear function, ax plus b. And lastly, if it's a constant, which is a special case over there, And then expectation of any constant is the constant itself. Lastly, even though we have seen this, we haven't seen this in so far, but if we're working with two random variables, then expectation of the sum is the sum of the expectation. Okay, so we'll see some examples coming up later in this course.